Okay, today I'll be explaining about how to find the inverse for K2. So what we're supposed to do is, we're supposed to use the ERO method, where we take the inverse of this and we are supposed to times it by the discrete message P. So K2, first we have to do is, since it's a 4, let's go to the second one. We're supposed to take row 2 minus row 1 and we'll get row 2. So we come back to this part here. Row 2 is 1 and row 1 is 1. So 1 minus 1 is 0, so you get your row 2 as 0. And you're supposed to do it for the continuous row, row 2, and then later you will get this. When you do 4R1 plus R3 equals to R3. So you keep doing it. As you can see, the pattern is going downwards. You're getting 1, 0, 0, and then you see you get a 0 here. So then as you go on, which is 5, 6, 7, 9, 10, these are all the equations where you will get, at the end you will basically get something like this. Supposed to get something like this.
It's not that clear though.
It's okay.
1 0 0 0 1 0 0 0 0 1 0 0 0 1. Yes.
So you're supposed to get basically something like this just now here. But however, in K2 there's a problem. In K2, at the end, you won't get something like this, which is this. In K2, you will actually get something like this where you're below, everything is 0. And there's a number here, which is something like this. As we have learned in maths, if you get something like this, it's considered no solution. Okay? So let me show you what answer you get. So basically, as you do all the equations here, your ending answer is something like this. So as you can see, here is all zeros.
Yes.
And here is all numbers. So it's something like this, which is considered a no solution. So since it's a no solution, you won't get to times it by the discrete message. So technically K2, there's no message. So yeah.
So that's all. Thank
That's all.
you.
And have a good day, Dr. Hassan. So today I will explain you how we get the determinant for this matrix K1. So basically, this sign of cofactor is important because we need to use that to calculate the determinant. So first, I pick any row or column you want that make you easy to find the determinant. So I choose this column, which is 2, 1, 1, 3. Okay, first, for 2 in this column, the sign is negative, so we put negative 2 outside, and then we close this column and row, and then we get 5, 3, 5, 4, 3, 1, and 4, 4, 3, which is this. So okay, and then the second column, the second is 1 we put outside, and then we close the row and column, and we get 1, 2, 1, 4, 3, 1, 4, 4, 3, and that and the other number
Okay,
in this
we get it.
column. So after we get this, we need to choose any or any row of column again to lastly find the determinant. Okay. Then after we get the 3 by 3 matrices like this, we can simply solve them by choose any row or column again, which is I choose this column 5, 1, 3. Then I close this, and then I got 4, 3, 4, 3, 4, 4, and then so it is 5. I close this, and 4 times 4 16 minus 4 times 3 12. So this is 4. So 5 times 4 minus 1, because this sign we got is minus. For this sign for at this 3 by 3 matrices is minus and this is plus. So basically we need to show this. Okay, like this. This is because the negative 1, 8 we got from close this line, 5 times 4, 20, 20 minus 12, 8. Okay. And then positive 3, we close this positive 3, and this we got 5 times 3, 15 minus 12, 3. So the rest is also the same by this matrix.
Okay.
So lastly, we get the determinant by sum up of the whole number that we get from this calculation, and then we get 7 as the determinant for K1 matrix.
That's all, Dr. Hassan. So this is the matrix that we're trying to solve. So after we get the determinant, we're gonna find the inverse for this matrix. To do that, we're gonna use triangle rule for each number in the matrix. So first of all, I'm gonna show you how we get this one. Firstly, we take 1 from here, from the top row and column, and then we're going to close the row and the column of this number, and then we will get 3, 5, 1, 3, 1, 1, and 4, 3, 3. And we will do the same thing for the rest of the number in the matrix. So in total, we will get new 16 whole numbers, and we're going to arrange it in matrix form again. Lastly, to find the matrix, we got not lastly. Okay, the product of the whole number, the 16 new whole number that we get, we transpose it by changing the row to column, and vice versa. After that, we're gonna multiply it with the determinant, with 1 over determinant that we calculate just now. After multiplying them, we will get this value, this matrix, the inverse matrix. After that, we're gonna multiply the inverse matrix with the given P matrix, and this is the end pula. This is the final answer or matrix that we get, which is no answer, no message. Thank you.
Assalamualaikum to Dr. Hassan. Now I'm going to show how to find the inverse of K3. Firstly, we must know the cofactor pattern, which is positive, negative, and will be alternate for each row and column. And then we choose one number. For example, I choose 2, so that this column, and then I close the column. So I write and we must make sure to follow the cofactor pattern, and then we close the row and column so that we can obtain 3 by 3 matrices like this. For example, I close this row and this column, so I get 3, 3, 3, 4, 4, 5, and 5, 5, 5, and we continue for each number in this column, and then we calculate to find the determinant, which is negative 21. Next, we must find all cofactors for each number in this matrix. For example, cofactor for row 1 and column 1. We close this row and this column, so we get same. We get the 3 by 3 matrices, which is 3, 3, 1, 4, 5, 2, and 5, 5, 4. And then we use triangle method to find the cofactor for the number at row 1 and column 1. So for C cofactor row 1 column 1, we get 7, and then we repeat all the same steps for all numbers in the matrix. And then when we already find all numbers or all cofactors, we must write and to obtain 4 by 4 matrices, and then we must transpose the cofactor, which is the row become column and the column become row. To find the inverse, we must 1 over determinant times the transpose cofactor. So like this, the determinant is negative 21, so 1 over 21 times with the transverse cofactor, and then we get this matrix. Lastly, we multiply P matrix that has been given in the question, multiply with the K3 inverse. So we get this matrix, and then based on the table of the alphabet table, we can find the secret message, which is as per head start.
Okay, my name is Kaishin, and I'll be explaining the question K3 using ERO method to solve. So the thing we need to do is we need to inverse the metric given in the K3. This one is the K3 that given. Okay. So we need to inverse the K3 and then times with the P and get the M message. Okay. So I will divide this one as part A and this one as part B. So okay, this one is the normal matrix we receive, and this one is the identity. So our aim for the ERO method is to change this metric into identity and part B become the inverse metric. So my working will be going like this. As we know, our aim is to make this as the identity, right? Like they have a diagonal 1. Okay, so I will be starting from the lower triangle, okay, then only to the upper triangle. So this is how my looking look like. So from the 1, I will go down to 3, 4, 5, and then I back to 3 again, then I come down 4, 5, and then I go up to 5, come down, and then the last will be 4. This one is the lower triangle. Okay, so my first step is I will use R2 minus with 3 times of the R1, and I will get a new R2. The next step is R3 minus 4 times of R1, and I will get a new R3. I will give an example that how I get the 0 here. Okay, so R3 we have 4 minus 4 times the R1 is this one, and it will be equals to 4 minus 4 equals to 0. So I get this value. Okay, the next step is R4 minus 5 times of the R1, and I get back a new R4. And continue with negative 1 over 9 of the R2, negative 1 over 9 times the row 2, and I will get another new row 2. So it follows the process, follows the working like this, and then I will finish the lower triangle at this part. As you can see, all diagonal 1 here. So as the working is going, you also can see that the first step, the 1 is already given, so we don't need to change everything. So this one is 2, and then follow like this. So you can see the 1 appear. So the working goes like this. Then I find the identity, the diagonal 1. So I complete my lower triangle. So now I will be going for the upper triangle. So the working will be going up, and then go to 1, and then go up to 4, then to 4, then come back to 1. Okay, so I will be using the R3 minus 2 over 3 of the R4, give back a new R, the diagonal 1. So I complete my lower triangle. So now I will be going for the upper triangle. So I will be using the R3 minus 2 over 3 of the R4, give back a new R3. The next step, we'll be using the R2 minus 5 over 9 of the R4, and I get back a new R2. So as it's going, then we can see it fills up the value. It fills up 0, 0, 0. Then we get the final answer is here. Yeah, so this one is the identity. Then this one is the inverse of the K3. So we will be using the inverse of the K3 and times P times inverse of the K3, and we will get the M hidden message. So I interpret it, it becomes as per head start. That's my final answer.